Hi, welcome to the Python CI talk, packaging, versioning, and publishing in one step. This presentation was originally recorded for the UW-Madison IT Professionals Conference 2022. I'm Rick Evans. So our goal setting out was to create a CI workflow to automate packaging, versioning, and publishing. And we wanted to do this in one step. We wanted to eliminate mundane, error-prone boilerplate code. There's a lot of it in packaging. We wanted to create and keep our APIs and libraries on the cutting edge with outlook that fixing small breaking changes every 8 weeks is much less painful than a large code migration every 8 years. And through the power of CI, we wanted to make this all seem like magic. A few topics I'm going to cover are Python packaging generally, dependency management and rethinking the requirements file, and using CI to automate the building and updating of the setup config file, semantic versioning and releases, testing with multiple Python versions, as well as a follow-up of a full demo of this GitHub-Action workflow. Let's talk about Python packaging. There are two methods we can use, either the setup.py method or the setup.config method. Both are very common. The setup.py method uses actual Python code, which runs on Pip-install, and that can contain arbitrary code, though that's rarely a good thing since most of the stuff contained should be static. So that leads us to the other method, the setup.config method. If you've never seen a config file, it's kind of like a YAML file. It contains static attributes, though it can contain directives and shortcuts used by setup tools, which will make it kind of feel like a language. The main plus here is it's automation friendly since it's a static file. Now I'll shortly mention the pyproject.toml method, which is a third way of doing this. It is coming eventually. It's currently experimental by setup tools, so I won't talk about it any further. So let's jump to dependency management. We decided to list our dependencies in our setup.config file. No sub-dependencies needed, no dependencies of dependencies. We agreed that version pinning leads to dependency conflicts for clients. Right, if we require one package which requires requests 1.1.0 and another package which requires a different version of that, that'll lead to dependency conflicts. I'm sure we've all run into this. Plus, right, we want to develop on the cutting edge. So we don't really want to be pinning our dependencies anyways. So what about requirements.txt? If we're putting all of our dependencies in our config file, then what are we doing with this file? We decided to rethink it. What should it contain? A lot of questions come to mind, right? Should it contain the required packages without versions, with versions? Do we just pip freeze to create the file? If we're using versions, which versions do we use? Is it even necessary? And to be honest, there's no great answer, so we just had to pick one. Here's what we decided. Our solution was to put pinned dependencies that were used during CI testing in our requirements.txt file, while unpinned dependencies get placed in our setup.config file. These will be used by clients. In other words, our requirements.txt file acts as an audit log for debugging client errors. Now we know if a client reports an error and they used one version of a dependency, we can benchmark that against what was ran during our testing. Maybe we can rerun tests. This will help us. And there's a tool for this. We can use pip tools, pip compile, and it will create a version pinned requirements file based on our setup config file. This way we can run our tests using either our pip-install dot or our pip-install -r requirements. They will install the same dependencies. Now we can move on to using CI to automate some of this stuff, specifically semantic versioning and releases. So here's a scenario. We want to manage a Python environment with many packages and dependencies. I'm sure we've all gone down this route where we git pull some packages and we install them locally. The problem here is you have to install each individual package. You also lack versioning in that case. You can't easily upgrade without git pulling and building again. So solution, use releases. Here's another problem. A package installed using the pip-install git plus syntax that you'll see all over Google and Stack Overflow won't obey the update protocol through pip-install. It doesn't understand GitHub's tag versions. So the simplest solution here is to publish the package to PyPI. It's free. though there is a lot of metadata to manage, and we'll go over that next. So we have several locations containing version numbers that all need to stay consistent. We have the version string in our init file. We have our latest GitHub release tag, as well as our latest PyPI release version. Now, technically, these can be out of sync, and you will see packages out there, not ours, but third-party packages that keep these out of sync. But if we want to create code on the cutting edge, let's release the latest version of what we have tested. And using Ralph LeKang's Python Semantic release GitHub-Action, we can do this. It'll read a section in our setup config file, it'll run, and it'll update all three. The version string, it'll create a new GitHub release, and it'll create a new PyPI release. And this is, of course, natively CI friendly. Let's talk about using CI to automate another thing, the building and updating of our setup config file itself. So there's a lot of metadata needed for publishing to PyPI. You can see on the left here, we have just the metadata needed for making a Python package itself, and on the right, all the metadata required for publishing to PyPI. There's a big difference, right? And if you look at this data on the right closely, a lot of it is pretty derivative. So the question is, how much of this can be programmatically detected and generated? Turns out a lot. So I made a tool called the Webpack dev py setup action, which acts as an autocomplete for all this metadata. All you have to do is define 5 attributes in a special section called the CI/CD setup-builder section. Those are the PyPI name, the Python minimum version, an author email, and some keywords, along with your install requires. And from this, it'll generate around 20 attributes. All this either detected through the 5 attributes on the left, the directory structure itself, or your GitHub repository. So now let's talk about using CI to automate testing with multiple Python versions. The idea here is we can't say we support multiple versions of Python if we don't test with multiple versions of Python. We want to support the most recent release version of Python. Right now, that's 3.10, plus some previous versions. So for that, we can define an attribute in our setup config file called Python min, and along with a tool that I created called the Webpack dev py versions action, it will read these supported Python versions. It'll create a GitHub output matrix, which can spawn jobs for each individual Python version. So now we can run our tests with each version side by side. So now we can combine this all together into one robust Python CI workflow for packaging, versioning, and publishing. Using the GitHub actions I've talked about and the metadata in our setup config file, we can get a fully generated setup config file, a requirements.txt with pinned versions that will act as an audit log, an updated version string, along with GitHub and PyPI releases. And we can do this all in one step. And here's a demo to show you what I'm talking about.